Okay, so hopefully you figured it out. Hopefully you figured out that z equals to the absolute value of x can be specified as x is greater than 0 and z is equal to x, or x is less than or equal to 0 and z is equal to minus x. Now what's important here is that you recognize the pattern. And the pattern is that the postcondition that describes such an operation, if this postcondition is used for an if statement, that has a very special form. It's a disjunction of conjunctions. Those of you who have taken a course in logic may remember that you learned that any logic expression can be written in canonical form that is a disjunction of conjunctions. So what does that mean? That means that anytime you come up with some kind of expression of what you want to compute, you will be able to besize that into a disjunction of conjunctions, and that may then guide you towards what the if statement should look like. Now we can do slightly better yet. Here is actually a worksheet for this very special case. Let's look at the postcondition. The postcondition in this case is a disjunction of conjunctions. It happens to have only two terms, but hopefully you will recognize how to generalize this. And what do we notice? Well, if we look at this, we have learned something about weaker and stronger predicates. We notice that G0 and R0 is stronger than G0 and R0 or G1 and R1. So what does that mean? If we pick G0 as our guard, and we can derive a command S0 that puts us in a state where G0 and R0 is true, then we know that after the if statement, the desired postcondition will be true. And similarly, if we pick G1 as a guard, then all we need to do is come up with a guarded statement S1 that leaves us in a state where G1 and R1 is true, and then we know that we are in a state where the postcondition is true as well. And the benefit of this is that each part is now simpler. It is simpler to deal with G0 and Q, leading you to a guarded statement S0 that leaves you in a state where G0 and R0 is true, than it is if you had the entire postcondition sitting there. So this simplifies matters. Here's an example where if x is less than or equal to 0, then you add 1 to a counter, otherwise you leave it alone. And this might, for example, be part of a loop to determine the number of non-positive entries in an array or something like that. And notice that it has this special form that we were looking for. Of course, a question is what part of the term in the disjunction should be the guard, and hopefully by looking at some examples you gain some intuition for that. There's probably a pattern, but let's not dwell on that. Okay, so here we have our worksheet. We know that there are going to be two guards, G0 and G1. We can easily identify those as x less than or equal to 0 and x is greater than 0. So we can fill all of that out, and then we can fill out everything else. We know what Q is, we know what G0 is, we know what G1 is, we know what R is, we know what R0 and R1 are, and we can simply fill out a big part of our worksheet up front. And then we're left with the simpler subproblems. How do we come up with a guarded command S0? Well, C is the only variable that's allowed to change. We know that some expression should be assigned to C, and then we can just go through the motions. We can take the weakest precondition of S0, leaving you in a state where G0 and R0 are true, and then from that we can conclude that the expression E0 should be C hat plus 1, and then we can look at the precondition for that section and find out that C is equal to C hat, and therefore we really want to compute with C, and then we're left with the desired guarded command. And then we can do exactly the same thing for the second part. So there we can either recognize that the precondition already implies the postcondition, and therefore we can just use skip, Or we can say that C is going to become some expression. You can push that into the weakest precondition. You can then say that that expression is equal to C hat. You can then recognize that C hat is stored in C, and then you're done. And then you can take away all of the annotations that had to do with the proof of correctness, and then you're left with the correct if command. So, for the special case where the postcondition is a disjunction of conjunctions, finding the guard and deriving the guarded command is greatly simplified thanks to these insights.